Hello. Moin moin. My name is Andrea. I'll be introducing some of the speakers here today and tomorrow, along with Abby, who you will see very soon, or even there in the hallway coming up this way. So without further ado, I'm going to introduce Max Rosin, our first speaker. Max is a technical communicator by profession, mechanical engineer by training, IT guy by accident, anthropologist by necessity, and a dad. He runs long distance, plays guitar, and enjoys cooking. So here's Max with Gyarados has pretty teeth. I don't remember if I pronounced that correctly. Gyarados has pretty teeth, dear, theater, Pokémon, and software docs.
Thank you very much. From an Amazon listing. Have you ever wondered what a world in which any item you desired was available at the click of a button would look like? The days of wondering are over. The ability for anyone to print guns, drugs, or iPhones is on the horizon. This means a radical change in the structure of society. The technology will prompt a new era of social revolution, and large companies and national governments must handle the challenge it presents. How will 3D printing change your life? Reality is stranger than science fiction. 3D printing will create future spaceships and robots to manufacture off-world colonies in orbit and on new planets. Astronauts will even enjoy pizza fresh from the printer. There's also the potential for a new society to emerge. Much as the previous industrial revolutions changed the world we live in forever, the coming third revolution will touch on aspects of every part of your life. From the kinds of work you do, to how you travel and what you eat, 3D printing has something exciting in store. Even leisure time will be affected. How 3D printing interacts with the Xbox will be closely examined. Are you already living in the future? Read 3D printing, Rise of the Third Industrial Revolution, to see how prepared you are. Hi, I'm Max, and I'm a tech writer. The question, what about modern technology products, especially computers, misleads people about its capabilities, has been with me for a long time. It likely started when I was still in university. During a course on additive manufacturing, I realized the abyssal gap between the promises of a 3D printing revolution and the very cool but also very limited capabilities of the actual technology. Today, 3D printing occupies niches where it actually makes sense, but it is largely gone from the techno-fantasies of the broader public. I'm convinced that this is due to the fact that enough people experienced one of these machines, elaborate contraptions made of delicate parts that only work with specific materials that require a lot of expertise to actually use. The material reality of technology has a sobering effect. Another product that has received a similar treatment lately is ChatGPT. As Gerben Wierda noted, there are a lot of articles that focus on how these systems will produce a revolution in work and society, but their link to the actual reality of what these models do is weak. Wierda sees two big misunderstandings. The first misunderstanding is that ChatGPT operates with words. It does not. It operates with tokens, essentially meaningless strings. We can demonstrate this by applying OpenAI's own tokenizer on some unusual words and numbers. The meaninglessness becomes particularly apparent if you look at something like calculations. This has nothing to do with math, what happens here. The other misunderstanding is that ChatGPT generates answers. So here's what actually happens. You start with your prompt in blue. The model then determines a list of possible next tokens and randomly selects one of them. The resulting string then becomes the new prompt, and the same procedure happens again and again and again and again. In this way, you can create basically text of arbitrary length until some kind of end token actually breaks the loop. You then, and only then, split the text into the original prompt and the newly generated answer. I believe both misunderstandings can ultimately trace back to ChatGPT's presentation. The product is presented like a chat interface for conversations with an all-knowing brain in a jar. Of course people misjudge it. It looks like something straight from sci-fi. But keen observers might have actually noticed something. ChatGPT only operates on syntax. It would actually be a category error to use it for tasks that require access to meaning. And it is. Let me illustrate. One way of reliably tripping up LLMs like ChatGPT is by inputting a completely new, obviously unsolvable logic puzzle that, however, mimics the form of already existing puzzles. Here I present ChatGPT with the impossible problem of moving 4 boats with 3 ferrymen. The puzzle is similar to other river crossing puzzles, like the one with the fox, the rabbit, and the cabbage, or the one with the jealous husbands. These problems are usually solved by strategically moving some objects back to the start. So likewise, ChatGPT starts shuffling boats back and forth until at some point it just moves 1 boat without a ferryman and declares victory. It even offers a very, very cool diagram of the solution. Like, try to parse that. This is not a machine for generating answers to unsolved problems. It is a machine for generating plausibly sounding dialogue, and maybe there's some use for that. But any correctness is purely by accident and mostly a function of the unfathomable size of the training data. My point here is not that ChatGPT's output is false. A lot of software creates false outputs. My point is that it creates a very powerful illusion of giving answers, summarizing, reasoning, while it is not doing that at all. In a Times article from 2023, Helen Toner wrote, "Try thinking of chatbots as improv machines." Well, improv, you say. In the early 1990s, Brenda Laurel proposed a very potent model of human-machine interaction, computers as theater. Laurel starts from the premise that representations are all we have when designing interactions with a computer. Given that theater is really good at creating pleasurable representations, she then elaborates a model for designing human-machine interactions based on theater theory. The interface is the stage, the program is the script, the users are both audience and actors, immersing themselves in the fiction, suspending their disbelief. The ultimate goal of Aristotelian theater is catharsis, the release of emotion through empathy. Since everything in theater is representation, this empathy must be created through illusions. It's not actually happening, right? Illusions are vital for theater to achieve its goal. This is very similar with computers. What matters is not so much what the computer actually does, how it shifts bits and bytes around. What matters is how using the computer is experienced. So UX designers create powerful illusions of browsing virtual files, traveling virtual spaces, or drawing on virtual papers. Illusions are not inherently problematic. For example, we can enjoy Copperfield's flying illusion without believing in levitation afterwards. But we can still leave the show with some very wrong ideas about what was just going on. The magician James Randi told an anecdote about when he saw said illusion together with a physicist who was very worried afterwards about the potential health risks from the giant magnet that must have been hidden under the stage. When Randy pointed out that Copperfield was simply suspended on ropes, the physicist could not believe it. After all, he did not see any ropes, did he? So this particular illusion may have been benign. Other illusions can be quite harmful. One particularly infamous example from popular media is the ticking time bomb scenario. I believe most of you will recognize it. A terrorist group has hidden some kind of bomb that threatens to kill thousands of people once the timer runs out. The only way for our protagonist to learn about the location of the bombs is by torturing one of the terrorists, who quickly caves under pressure and gives up the crucial information. There are dozens of variations of this trope. It can even be found in children's media like Zootopia. There's actually an article about that. From a theatrical standpoint, such a scenario makes a whole lot of sense. It's a mechanism for revealing information that moves the plot along, it's high tension, it provides an opportunity for a protagonist to agonize over ethical decisions and make a tough choice. But the scenario is also completely absurd. It rests on completely unrealistic assumptions and is practically unheard of in real life. More importantly, torture is provably ineffective at obtaining truthful information, especially under time pressure. But yet the trope seems to be convincing. Asked about the use of torture by the US, former Supreme Court Justice Antonin Scalia reportedly said, "Jack Bauer saved Los Angeles. Are you going to convict Jack Bauer?" Referring to the character from the series 24 played by Keith Sutherland. And he's not alone. Chuck Schumer defended torture on similar grounds, and so did Alan Dershowitz. What makes the ticking time bomb scenario so convincing is its theatrical enactment. The audience does not merely observe it, they immerse themselves in it. They are invited to empathize with the torturer and experience torture as an effective means for a righteous end. Sure, the scenario does not work if you think it through, but you are not thinking, you are experiencing. Similarly, representations in computer programs can induce harmful beliefs. As Weizenbaum said, computers enable fantasies. Take, for example, the big data myth, the belief that the future could be predicted if one just had enough data and the computing power to process it. It's not hard to see why this is misguided. Correlation is not causation, judging individual cases from averages is fallacious, and so-called black swan events are entirely unpredictable from historical data. And yet, many companies and governments happily rely on risk scores, AI fraud detection, affect recognition, predictive policing, chart analysis, you name it, without ever truly wondering whether any of it actually works. Which it often does not, as Raji et al. Point out in their paper on the fallacy of AI functionality. As technical writers, we should reject such dishonesty. Endorsing illusions is antithetical to technical communication. Documentation must be honest and reliable, otherwise it's useless. The demand for honesty is a direct outflow of demanding correctness, completeness, minimalism, and conciseness. Dogs are a part of the product, so we should heed the words of legendary industrial designer Dieter Rams, who said, "Good design is honest. It does not make a product appear more innovative, powerful, or valuable than it really is. It does not attempt to manipulate the consumer with promises it cannot keep." Because, again in Rams' words, designers have an educational task because he or she participates in the social and cultural development and cannot deny this responsibility. Stephen Krug's "don't make me think" is simply not an option here. But if computers always require representations, how can we make sure that our designs are not misleading users? In theater, there's an answer. Bertolt Brecht's epic Theater. Brecht vehemently criticized what he called experience theater. For Brecht, empathy was too individualistic to understand reality. In his view, to understand reality through theater, one must reconstruct the reality of theater first. This means making clear to the audience that they are watching a play in a theater, a physical building, a workplace, a business, and how all of that shapes what they are seeing. His goal was critical distance, not empathy. This does not mean that theater could not be fun, quite the opposite. Brecht's plays have a lot of jokes and songs, aiming for a happy critique. To show the reality of theater, Brecht used what he called Verfremdungseffekte, literally estrangement effects, or V-effects. By taking something familiar and making it strange, he hoped to incite curiosity and astonishment. These moments of confusion should move the audience from an old understanding to a new one. Examples of V-effects include fourth wall breaks, explanatory text on stage, actors saying one thing and then doing the other, realistic costumes and props in minimalist settings, or conducting scenery changes with open curtains. Similarly, we might say that if we want to understand reality through computers, we must reconstruct the reality of computers first. But how? Well, transferring Brecht's ideas to HCI, we arrive at something like maybe seamful design, deliberate friction, and designs that invite inspection, tampering, and modding. But what does it mean to transfer these ideas to dogs? In his writings about theater, Brecht talks about the literarization of theater. The thought is that reading about something is a more sober way of engaging with it than actually experiencing it. So staying with our computers as theater approach, we could talk about the literarization of computers. Well, this sounds a lot like software dogs. Brecht encouraged reading plays. The analogy would be reading source code, maybe. Brecht also put visual captions on stage, and that's a practice mirrored by writing UX microcopy. But what about proper documentation like manuals? The closest analogy to docs I can think of are reading guides or cliff notes. While Brecht never spoke about reading guides, I think they would have fit very well into his framework. The analogy between reading guides and docs is actually rather striking. As literary genres, both are severely under-researched from professional literary scholars. This might be due to their dirty image as something one should not need, or that is only used by people who lack the skills to deal with the actual product or text. Maybe it's due to our society valuing famous authors and successful designers more than lowly writers of textbooks and manuals. But be it as it may, both genres share a lot of characteristics. Both are usually compact works on a single topic, typographically unambitious and cheaply produced. That's not an insult, that's just what they are. Both frequently employ stereotypical chapters and elements, such as glossaries and overviews, a practice we know as information typing. They're both action-oriented in the sense that they inspire a specific approach to a text or product, but invite little meta-reflection. They rarely assume any didactic role, but instead further professional practices like information retrieval, quick orientation, or selective reading. Both reading guides and documentation can be used to substitute the self-guided exploration of a text or product. They provide additional context for interpretation or support text or product-related tasks by offering ready-made approaches. Last but not least, both frequently offer example solutions for real-life tasks in the case of docs, for homework assignment in the case of reading guides. Reading guides are ways, and docs are ways to engage with their respective subjects, not through illusions, but by peering behind the curtain. This is really obvious with video games. Video games are the essential example of computers as theater. The player literally acts out a fictional scenario on their computer. Genre names like cinematic shooter or immersive simulation indicate how close computer games actually are to theater. Casually playing a video game usually requires little documentation. The mechanics that constrain possible actions are made intelligible through theatrical devices like dialogue or scripted events. Immersion is of utmost importance. The machinery of the game is usually hidden, and experiencing it is commonly considered a bug. This changes with competitive play. In this case, the game is primarily considered a computer program to be operated masterfully. Documentation, often made by the players themselves, is very much required, a practice that is known as theory crafting. Theory crafting is an attempt to mathematically analyze game mechanics in order to gain a better understanding of its inner workings. Immersion is practically irrelevant. Quoting from an ethnographic study on theory crafting in the game of World of Warcraft, play from theory crafting perspective is about the correct input of and output of numbers, challenging the narrative of play as something free and frivolous. With that in mind, let's look at Pokémon. To give you a quick overview in case you've never heard of it, Pokémon takes place in a fictional world inhabited by a variety of monsters, the eponymous Pokémon. Here. Some humans, called trainers, catch these monsters and use them to battle each other. The player plays a young trainer traveling the region in order to become the ultimate Pokémon champion. This is achieved by visiting all major cities, beating the local gym leaders, and finally confronting the top 4 trainers and the reigning champion. Along the way, the player assembles a trusty team of Pokémon and trains them to fighting other creatures while solving various smaller and larger mysteries. The games themselves provide little technical explanations about how to play. They come with a small manual that explains the core mechanics and controls, but no one actually really uses it or needs it. The games do a pretty good job at explaining themselves. In line with the idea of computers as theater, these explanations are almost invariably framed in the terms of the representation. The so-called Pokédex provides a particularly stark example. The Pokédex in-game is effectively a database application that enables the player to gather and retrieve information about the various Pokémon. Filling this database is one of the game's objectives. Within the game, the Pokédex is framed as a high-tech gadget the player gets after solving the initial quest. To understand how far the developers go with this representation, let me pull your attention to the striking similarities between the presentation of the Pokédex and the platform it is played on. For example, this image here shows the Nintendo DS, and this is an artwork of the Sinnoh region Pokédex and how you can actually see it on the screens. This is the upper screen, lower screen. This is peak theater. But despite all the illusions, treating the game as a computer program can still be worthwhile. This is in fact a common strategy when speedrunning the game. Speedrunning is the practice of trying to finish a game as fast as possible. As of today, the current record for Pokémon Red, the first game in the series, stands at 1 hour, 43 minutes and 40 seconds for any percent glitchless, and an absolutely silly 1 minute, 17 seconds and 577 milliseconds for any percent. Any percent here means just getting from the start screen to the end screen, while glitchless refers to the additional requirement that you cannot exploit any of the game's bugs. The category names alone should indicate that speedrunning almost invariably treats a game not as an immersive experience, but as a computer program, whose technical quirks must be exploited to the highest permissible degree. For example, and this is an example from community-made documentation. For example, look at this recommended path through an area called Rock Tunnel I pulled from a speedrunning strategy guide. If you look closely, you can see that it is not the shortest path possible, for example here, but it's the fastest because it avoids lengthy animations by approaching the various NPCs directly for combat instead of letting them see you first. Apropos skipping animations, another interesting strategy is called red bar. During combat, if your Pokémon has low health, the HP bar turns red and a dramatic chime is played. During this situation, it is possible to skip animations and sound effects, maybe to make a tense situation feel more snappy. But speedrunners only care for how this can shave off multiple seconds of any trainer fight. So you end up with meticulously calculated documentations of fight sequences to incur just the right amount of damage at the right point of time to use red bar for as long as possible. All of this requires ridiculous amounts of documentation of the inner workings of the game. Let's have a look at the depth of these docs. A good example are the so-called effort values. Effort values are a hidden property of every individual Pokémon and a crucial element in calculating its power. Every Pokémon has so-called stats like speed or strength, which determines its behavior in combat. These are strongly influenced by the type and amount of effort values the Pokémon acquired during the game. The game never explicitly explains effort values or even mentions them. Asked about this in an interview, Shigeru Umori, longstanding designer and director of the franchise, explained that they did not want to present Pokémon as data sheets, but as pets. Again, Aristotelian theater, empathy through illusion. But of course, this is exactly how competitive players see it. They reverse engineered the data structure and algorithms in order to maximize their Pokémon strength. To give you a taste to the extent to which competitive players treat these games as computer programs, here's a screenshot of the reconstructed data structure of an individual Pokémon, which can be used for all sorts of optimizations and hacks. See if you can spot why a lot of values can only go up to 255. There's a reason for that. It's because it's a byte. So, is this what useful documentation looks like? In the face of enchanting UX magic? Drilling down to every last bit of every data structure? Yes. I think this is the best option we actually have. Especially against the odds of powerful illusions. Sure, you could ask your UX guys to introduce more friction into the design. Good luck with that. I'm sure management will love your proposal to make the product less convenient to expose its limitations. So what else are you going to do? Just like fact-checking does very little to convince the conspiratorially minded, I do not believe dogs have the ability to cut through powerful illusions created by user experience. Personal experience overrules impersonal information every time. Maybe we can use this to our advantage. As you've seen with video games, understanding computers as computers enables users to operate them more effectively, more efficiently, more competently, which is also an experience, right? So maybe instead of trying to fight the illusions, docs should provide users who want to look behind the scenes with comprehensive, detailed technical information. The eventual success of those who see computers for what they really are will do far more to change minds than any tech writer could ever hope to achieve on their own. For the field of machine learning, I would like to point out 2 papers that inspired what I have in mind here, which is Datasheets for Datasets by Timnit Gebru et al. And Model Cards for Model Reporting by Margaret Mitchell. This also does not mean that dogs must be boring. Quite the opposite. Remember, Brecht's plays had jokes and some banger songs that I cannot get out of my head. Again, 2 good examples. The ActivityPub specification is really well written and features some cute but also very useful diagrams. And I personally enjoyed the documentation for the Python library Beautiful Soup 4 so much that I spent an entire weekend working through it just for fun. This is not weird. I think it is appropriate to end this presentation with a quote by somebody who, more than anyone I know of, represents the idea of understanding computers as computers. Hacker legend and founder of the Chaos Computer Club, Wou Holland. When explaining in an interview why copy protection software goes against the fundamental essence of the computer, he said, "The computer is a machine for copying and changing bits." I have nothing to add. Thank you for your attention. So, I think, I'm not sure? Yeah. Okay. Yeah, oh, okay. Oh, that's nice.
First things first, thank you for the talk. A seamless transition from Brecht to Pokémon, I think. And I'm going to just queue up a Slido interface where you've got a couple questions. I'll lead with one of them, and I've got another one myself, just in case we might not have any other questions. Somebody's asked or stated, many people don't like admitting that they're not operating from rational bases. How to deal with the emotional resistance to that admission?
That's a tall order. I don't know. I think it's just a good idea to, as I said, just provide good information, enable people who want to look behind the curtains to do so, and, well, hope for the best, prepare for the worst, I think. That's
Short but sweet. Hope for the best, prepare for the worst. I appreciated also just how often you pointed to the fact that, well, fact or not, that Brecht made the observation that reading a performance or reading a play makes one engage perhaps more so than sitting in the audience and taking it in. And that docs sometimes or often don't have the power to cut through a very powerful UX design. I was also thinking of the presentation that we'll have at the end of the day from Michel Mulders, who's going to speak about developer experience and ways to craft one's documentation or knowledge stuff into more interactive forms. And I guess my own questions have to do with I don't know, I don't want to use fight terminology, but managing the reality that there are folks, there are people who want to learn stuff but may not wish to engage. How do we perhaps nudge them into reading and engaging and wanting to learn that way?
Well, I think that's why I like the community-made stuff from competitive play so much, or why I find them so fascinating. Like the speedrunning community, especially, like, I'm not a speedrunner, I just like to watch this stuff, is super engaging. Like, this is super fun. For example, a lot of the stuff happens through videos or through big events like AGDQ. So it's super fun to actually watch. And they talk about the entire time what they're doing. They talk about the program. They explain the glitches along the way. So this is what I mean by it still can be fun, because it arguably is. But like you see, like, for example, one of the things that was super fun was like one speedrun of Bloodborne. And like if you don't know the game, you have no idea what it's about. Like you always hear, but it's so fun because the player explains everything they're doing and makes jokes, and it's a completely different experience of the game. But it's super technical, like explaining every button press and every jump and how to to position yourself like pixel perfectly in certain situations and so on. So I think there is room for videos that do that, as long as they stay true to the technical reality of what they're describing. I don't think there's a contradiction necessarily. Right. Just like Brecht, he had songs, he had jokes.
Bangers.
Bangers. Yeah, like Three Penny Opera.
Yeah, the way I'm understanding your response is also perhaps in a scenario where we have video that complements written documentation, we are bringing back this more human element. Maybe it's a bit more engaging for folks who may not be able to read with that attention.
Yeah, or for example, the activities pub spec I actually like. Like, these are super cutesy graphics in there, but they're still super technical. Like, they are precise, they are accurate, but also kind of nice.
Fun. Let's see. I'm just looking through Slido. We still have a couple minutes for questions if anybody else would like to post some. Oh, okay. Well, a couple people have asked for some tips you might not have at this moment, but might you have some examples for how one can implement these ideas, getting the audience's attention, and so on?
Ooh. Again, I think like multimedia formats are likely a good idea. Another creative idea is, I guess this was there's like a game for learning the controls of the Vim editor. Like
Yes.
There's like an entire video game. Maybe that's a cool approach. Like learning Vim, otherwise it's like not fun. But playing a game like where you like learn how to move or how to interact with stuff, and then thus learn all the key bindings. That's like maybe a cool thing. And also there can be joy in actually nerding around with something fully tech. Like it can be fun to just take something apart and look how it works.
Indeed. Okay.
And you can enable that with docs, of course, in some kind of way. Maybe you show how to take something apart. Maybe that's, but this of course requires collaboration of the designers, right?
A dream, or a reality for some people. Any last thoughts you'd like to share? Or?
No, actually not. Thank you so much. Oh, one does, yeah, that's not really. If you want to learn more, I'm going to put up a full transcript, including footnotes and references on the little website you see on the, but it will take me a couple of weeks, so
Yes.
give me 2 or 3 weeks. But if you want to learn more, it will go up there.
Great. Thank you again.
Thank
you,
you.
everybody.